Patty Simpson with Simpson Math. In this video, we're going to find an inverse function. So here we have a linear function, and I'm just going to find its inverse. There are 4 steps we're going to follow for finding the inverse function. Our first step is we're just going to replace our f of x, this function notation, with y. We know that f of x is the same thing as our output y. So here, I'm just going to replace this f of x with y. Then, step 2, I'm going to swap my x and my y values. So everywhere I see a y, I'm going to write x. Everywhere I see an x, I'm going to write y. And we're doing that because in our inverse functions, our inputs and our outputs just swap places. Now we're going to solve for y. So I'm going to subtract 4 from both sides so that I end up with x minus 4 equals 1/2 y. Then I'm going to multiply both sides by 2, or you can divide by 1/2, which you multiply by the reciprocal, so we multiply by 2. This just becomes 1, and 1 times y is just y. Distribute that 2, so that we end up with 2x minus 8. So now the last step, now that I've got y solved for, I got y by itself, the last step is to replace y with that inverse function notation. So this just says that 2x minus 8 is the inverse of my f function. And it makes sense because here I was adding a value, now I'm subtracting. There I was dividing by 2, and here I'm multiplying by 2. We can also check to make sure that this is an inverse by simply picking a number to put in and getting an output, and then taking that output and putting it in here, and this should reverse to go back to the input. Let's try it. Pick some x value, whatever you want to pick, to plug in. How about 2? We'll just plug in some input into this function, substitute in. So 1/2 times 2 is just 1. 1 plus 4 is 5. Now, if this is its input of this inverse, then I'll input this into the inverse, and I should get out 2. So we can check ourselves just to make sure they really are inverses. So I'm going to input the 5 into my inverse function. So 2 times 5 minus 8. And if they truly are inverses, then I'm going to get out a 2. That should be my output. 2 times 5 is 10. 10 minus 8 is 2. Sure enough, my input and my output swapped places. And that's what makes an inverse an inverse. We could also check to make sure that they're inverses by finding the composite. I could take this and find the composite function, f of negative x, and if I did that composition, it should equal x. And then I could do it the other way, where I take my inverse function and put in the original function, and it too should equal x. And if that's true, then by definition, these two would be inverse functions. So 4 steps to finding an inverse function. And the main thing is we're swapping our x's and y's and solving for that y. In the next video, we'll do another example of finding an inverse. Math Made Simple at Simpson Math. Thanks for watching.